Hello, geometry students. Welcome back. Thank you for tuning in. Today's Flipgrid is right there. Go answer it. Good fun. If you are here, you have already found the YouTube lesson. Now, pause the video. Try this problem in your notes. What is the perimeter of this rectangle right here? And then, once you figure that out, what is the perimeter of this circle? Unpause the video and do it with me. Remember that perimeter is all the space around an object, or the distance around an object, excuse me. So here we have 6. This, because it's a rectangle, we know that all parallelograms have opposite sides congruent, and a rectangle is a parallelogram. So this must also be 10 centimeters, which means this is also 6 centimeters. So all I have to do is 10 plus 6 plus 10 plus 6, which is 20 plus 12, which is 32 centimeters. Don't forget your units there. 32 centimeters. Okay. Now on to the circle. Well, the circle doesn't have sides, so that makes it a little bit different and a little bit interesting. That's actually what we're going to learn about today. So, today we begin chapter 11, which is all about circumference, area, and volume. You can see I have lumped things together because we don't have a ton of time left in the year. What we're doing is we're lumping sections together. So this lesson will be on 11.1 and 11.2 together. It will be on circumference and area of circles. Arc length and sectors will be extra. So that'll be at the end of the video that you can go and watch about arc length and sectors if you want. If we had not had to rush through everything this year, you definitely would have learned about arc length and sectors. So I would recommend that you stick through to the end of the video and watch it if you have the time, but don't stress yourself out. Take care of yourself right now. 11.3 is areas of polygons. We're just going to skip 11.4. Don't even worry about it. We'll do 11.5 and 6 together, and we'll do 11.7 and 8 together. But for today, we are going to look at 1 and 2, circumference and areas of circles, and arc length and sectors. Okay, so today, yep, just what I talked about, circumference, areas of circles. This will be extra, not required for homework or tests. So our learning target is I know what the area and the circumference of a circle are. And the success criteria is that I can find the area and the circumference of any circle. So, circumference, area. Circumference, area. That's what you need to know by the end of today. And arc length and sectors if you want to. If you want to. Okay, so let's start off with the circumference of a circle. Now, at the beginning of the lesson, in our entry task, we looked at trying to find the perimeter of a circle. So the perimeter of a circle is actually called the circumference of a circle. And we have a special formula for it. We actually have 2 formulas for it, but they're basically the same thing. Make sure that you pause the video and write down what is in this red box. Picture, words. These boxes are especially important. And then unpause it and talk about it with me. So you can see that this first box right here says the circumference is equal to pi times the diameter. It says where d is the diameter. Now, what happens if I don't have the diameter? What happens if I only have the radius? Well, we have another formula here that says c is equal to 2 pi r. And that's 2 times pi times r, where r is the radius. So you can see that these formulas are actually the same because the diameter, that's just like here's the diameter, but if I take half of the diameter, I have a radius. So 2 radiuses make 1 diameter. So the diameter actually is 2r. That's why I said they're one and the same. But yes, these formulas, remember them. Remember them. They are what will help you with your homework for today. All right, moving on. This is a fun fact, so you don't have to write this down, and in fact, you could skip this part of the video if you want to, if you're really stressed and gotta do that. But where on earth does the circumference of a circle come from? Where does pi come from? So, think about if you take a square inside a circle, and this red line right here is the diameter of that circle. Now, when I increase the number of sides, I turn this square into an octagon. I turn the octagon into a dodecahedron, or excuse me, a dodecagon, not a three-dimensional figure. But as I increase the number of sides here, it gets closer and closer to a circle. The more sides I have, the closer I can get to being a circle. And as the number of sides increases, polygon approximates the circle, which means it gets closer and closer to a circle, and the ratio of the perimeter of the polygon, because we can calculate the perimeter of a polygon, it's nice and easy to just add up all the sides like we did with that rectangle. The ratio of the perimeter to the diameter of the circle approaches pi. Pi is a beautiful, beautiful number, and it appears many more places than just in geometry in circles. You can find them in eigenvalues for like a vibrating string problem. You can find them in Fourier transforms, Fourier series. You can find them in topology. You can find them in vector calculus, Cauchy's integral, the Riemann hypothesis, the Riemann zeta function. All things that you will learn about if you go on to study higher math in college. So yes, pi is very special. Pi is very important. This is where the formula for circumference comes from, in case you were curious about it. So now, let's move on to our first example. Let's use that formula for circumference. So first thing I see, circumference of a circle with a radius. Okay, so we're going to want to use circumference is, 2 pi r, because that's the function with the radius in it. If I tried to use circumference equals pi times diameter, I don't have the diameter, I have the radius. So we want to use this. We want to use this formula, not this one. Okay, so actually let's use different colors too. So this is our guiding light through this problem. Now part A. So circumference equals 2 pi r. Oh no, my calculator! We're in too deep. I'll be right back. I gotta get my calculator. I'll be better prepared next time. Okay, so circumference equals 2 pi r. That means 2 doesn't change, pi doesn't change, but remember the radius is 9 centimeters. So that r will change to a 9. Don't forget centimeters, because we'll have our units in the end. So circumference equals, and I'm just going to put in my handy-dandy calculator, 2 times pi times 9, which is, if they want you to use specific, exact answer, we would just do 2 times 9, which is 18 pi centimeters. And that would be our final answer, if we wanted an exact answer. But if we want to approximate, we can just put this in a calculator, 18 times pi, and we will get approximately 56.5 centimeters. I would prefer this one. I prefer this answer, because what does 18 pi centimeters look like? I don't know. But I do know what 56.5 centimeters looks like. So I prefer this type of answer. But know that if you want it in exact form, this is exact, and this is an approximation. Alright, let's move on to B. B, a radius of a circle with a circumference of 26 meters. Oh, now we're trying to find the radius, and they gave us the circumference. So we're still going to use circumference equals 2 pi r. But now I know that the circumference is 26 meters. So 26 equals 2 pi r. And I don't know what the radius is, but I'm trying to find it. So remember, this is just like any other algebra equation that we would solve. If I have 30 equals 5x, how do I get x by itself? I just divide by 5 on both sides. And, whoops. That cancels out the 5s, and we get that x equals 6. This is the exact same thing because pi is just a number. Pi is just 3.14159, yeah. So, because pi is just a number, what we can do is we can just divide by 2 pi on both sides. Cancel out the 2 pi's. 26 divided by 2, that's 13 over pi equals r, and there's your exact answer. But if we want a more precise answer, or excuse me, a more approximate answer, we'll do 13 divided by pi, and this will be r is approximately 4.1 meters. Remember, I prefer this answer. This is the exact form. So this is the exact. I prefer the approximation because I know what 4.1 meters looks like. I don't know what 13 over pi meters looks like. Okay, there you go. First example of the day done. So, the formula is your guiding light through these questions. Put your formula down first, and then plug in the information they give you. If they give you the radius, plug the radius in there. If they give you the circumference, plug the circumference in there. And solve for what you need to. Okay, let's check and make sure that we were right. Booyah! Centimeters, look at them including their units, and 4.14 meters. Wonderful. Alright, more important information. So the two things we needed to learn about today were circumference and area. We already learned about circumference up there, so now it is time for the area of a circle. I have a nice way of remembering this formula. And remember, on your tests, they're open note, open book, so don't worry about memorizing these formulas, but it doesn't hurt to memorize them. Helps problems go faster. But don't worry about memorizing them. Don't stress out about it. So this is the formula for the area of a circle. Area equals pi r squared. And I have a really dumb way of remembering this. This is one of the few things I learned from my math teachers in high school, was how to remember this. So you see how it says pi r squared. So the way you remember it is pi r not squared, pi r round. Yeah, So pi r not squared, pi r round is how I remember this. And again, r is the radius of the circle. Okay, seems easy enough. Let's see if we can use it. Oh, and make sure that's written down. Make sure that's in your notes. Okay, let's see if we can use it. So I'm gonna write our handy dandy formula over here. Area equals pi r squared. Okay. Now, let's look at A first. I want the area of a circle with a radius of 2.5 centimeters. So I'm going to start with my formula. Area equals pi r squared. I don't know what the area is, but I do know that the radius is 2.5 centimeters. Whew, that's squared. So now, if I want the exact answer, I'm just going to do 2.5 squared. And I'll take 6.25. That's what 2.5 squared is. And tack that pi on the end. Here's our exact answer. But if I want the approximate answer, I will get 19.6 centimeters squared. Don't forget, when we're looking at area, so perimeter is one-dimensional. Perimeter is one-dimensional. I'm just looking at length. But area is two-dimensional. Instead of just looking at length at one dimension, I'm now looking at 2 dimensions. Area's two-dimensional. We're talking about the space inside of something. We're talking about the space inside of this circle. So it is two-dimensional, which is why we square it. Power of 2 for 2 dimensions. Awesome. Okay, remember this is the answer I want. Next, we will look at B. We want to know the diameter of a circle with an area of 113.1 square centimeters. Okay, so let's put our handy dandy formula down. And we know that the area is 113.1 centimeters squared. We don't know what the radius is. We're trying to find the diameter. Is there a diameter in our formula there? No. Oh, no. Oh, but wait. Remember that if I can find the radius, 2 of those make up a diameter. Because here's a radius, and here's a radius. So radius plus radius equals diameter. Or 2 radiuses equal a diameter. So if we can find the radius, all we have to do is multiply it by 2 to get our diameter. Okay, so let's solve for the radius, and then we'll just multiply it by 2 to find our diameter. Cool. So to get the radius by itself over here, I need to get rid of that pi. So we'll divide by pi on both sides. Whoops. 113.1 over pi equals r squared. How do I undo a square? I take the square root. So now, woo! If you want an exact answer, it will be 113.1 over pi, the square root of all of that. Do you know what that looks like? No. No. Which is why we are going to take the square root of 113.1 divided by pi. And that gives us approximately 6. Oh, approximately 6. 6.00007. So we'll just do approximately 6 centimeters. Approximately 6 centimeters for r. And remember, now that we have r, we can easily find the diameter by multiplying by 2. So the diameter is approximately 12 centimeters. Ta-da! Okay, let's double check that we were right. 19.6 square centimeters, just like they said. Radius is about 6 centimeters, so the diameter is about 12. Oh yeah, got it right. Okay, that is all the required material for today. Oh, goodness, we are not doing YouTube live streams anymore. I should have changed these notes before we started recording. Google Meets. Google Meets. And that is from 12:30 to 3 every Tuesday through Friday. Yes. So, if you have questions, please ask. Not on YouTube. in the Google Meets at these times. Your questions deserve answers, so please ask them if you have them. This was all the required work for today. So your homework for today looks like this. This is just like examples 1 and 2. Find the indicated measure, circumference, diameter given the circumference, radius given the circumference, and so on. And then these are about area. So circumference and area. Now, if you're feeling like you got more energy to do some extra work, you would have learned this if we had been in normal school. So I recommend that you watch the rest of the video so that you can see how to do these bonus homework questions. And 1 point each. Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? 12? You could get 12 out of 10. You could get 22 out of 10. You could get a 220% on this homework if you did all of the bonus questions. Wow. Wait, no, I'm gonna keep that there. I'm gonna keep that there so you can see it. Yeah. And I'm gonna launch you so that you can finish watching the video if you don't want to do the bonus. But after the launch, we will dive straight into learning how to do those bonus questions. So, your launch for today. Never limit yourself because of others' limited imagination. And never limit others because of your own limited imagination. So, let's talk about what that means. Let's split it up. The semicolon separates two independent clauses. So let's separate this into two pieces. First, this piece. Never limit yourself because of others' limited imagination. So, if your imagination is limited, it's hard for you to imagine things. So maybe others have a limited imagination and they say, you could never be a doctor. You're not smart enough to be a doctor. That's them having a limited imagination. Never limit yourself because of others' limited imagination. So never tell yourself, wow, I never could be a doctor because I'm not smart enough. Like, and they don't think I'm smart enough. Like, just because they don't think you're smart enough doesn't mean you aren't. Just because they don't think you'll work hard enough doesn't mean you can't. So never, never limit yourself or tell yourself you can't do something just because somebody else thinks you can't. And part 2 of this, never limit others because of your own limited imagination. So never say, ooh, that person, ooh, they're not very good looking. They'll never get married. Or something like that. Who do you think you are to tell somebody else what they can and can't do? So never limit others. Don't put somebody else in a box of this is who they are, this is who they get to be, because of your own limited imagination. So, the key takeaway from this, don't limit your imagination. You can do whatever you put your mind to, and everybody else can do whatever they want if they put their mind to. So, don't limit yourself, don't limit other people. Encourage everybody to be the best them that they can be. Okay, that's your launch for today. Thank you for watching. Have a wonderful rest of your day. Take this launch with you as you go throughout your day, and thanks for watching. So that was the portion of the video on the required homework. So if you only want to do the required homework, bye. You can stop the video now. But if you want to know how to do the extra homework, let's keep going, shall we? So, this is about arc length. Arc length. So, arc length is a portion of the circumference of a circle. So remember, we just learned... Whoa, that's a bad circle. Better. We just learned how to find the distance around this circle. So, if I want, which is, the circumference is 2 pi r. There's another formula for it that is pi d. So if I wanted to find the circumference of half of a circle, well, all I have to do is take half of the circumference. Half of the circumference gives me this portion of the circumference right here. And we call this an arc, right? I mean, this would be a semicircle, but this arc, if I want to find the length of an arc, all I have to do is figure out what portion of a circle is this. Is it a quarter of a circle? Then I would just be looking at this, and this would be a fourth of the circumference. Am I looking at an eighth? Maybe I'm just looking at this piece, then that would be an eighth of the circumference, and so on and so forth. And that's what this fancy, scary looking formula says over here. We know that there are 360 degrees in a circle, total. So, if I want to look for this portion of the arc length, all I have to do is figure out what angle is that? What angle is that? Maybe it's 60 degrees. Ooh, 60. Maybe it's 60 degrees. So now all I have to do, I'm taking 60 out of 360, and I'm taking that portion of my circumference. All we're doing is taking fractions of the circumference. And an easy way to make that fraction is by taking it out of 360, since there's 360 degrees inside of a circle. And that's what this says right here. The length of AB, so that we're looking at this diagram right here, the length, not the measure and length are different. The measure of an arc is the same as this angle, but the length of an arc is the measure of the arc over 360 times 2 pi r. And you can see that this is just the circumference. 2 pi r. That's the circumference right there. So you're just taking the measure of the arc divided by 360 and timesing it by the circumference. Now that might seem a little confusing, but we're going to go look at examples of it right now. So hopefully seeing examples will help clear things up. Okay, so we want to find the arc length of AB, which is this right here. So remember, we're taking the measure of AB over 360 times the circumference. So first, let's find this circumference. Circumference is 2 pi r, which in our case is 2 pi, there's our radius, r equals 8. So this is 16 pi. Now in this case, leave it as the exact answer. This is why I showed you the exact answer and the approximate answer, because in this case, you don't want to plug something approximate in right here. You want to plug the exact number in right here. Okay. And now we need the measure of AB. Well, remember that the measure of the arc AB is the same as that central angle. So, the measure of AB is 60. So, here is our I mean, it's not the finished final answer, but here's our arc length. There it is. You take the measure of the angle over 360 and times it by the circumference. And now, all we have to do, 60 divided by 360 times 16 pi is approximately 8.4 centimeters. Don't forget your units. So the arc length is approximately 8.4 centimeters. Okay. Ooh, we're gonna need more space for some of these. Let's get a closer look. Different color. Ooh, and now we're finding the circumference of the circle. So now I'm still gonna take, let's see, I'm gonna take the 40 over 360 times the circumference. So this is the piece that I want to look for. Oh, and I know my arc length. Okay. So 4.19 equals my 40 degrees out of the total 360 degrees times the circumference. And I want to find the circumference. Oh, that's okay. That's nice and easy. All I have to do is multiply by the reciprocal of this fraction. So, do a different color. I'm going to multiply by 360 over 40. That cancels out the 40s, cancels out the 360s, and we got to do that to both sides. 360 over 40. So 4.9 times 360 divided by 40 is, ooh, this is exact too, this isn't even approximate, 37.71 inches equals the circumference. And because it's exact, I can use an equal sign. This is not approximate. I only get that number of decimals, 37.71. So, awesome, awesome, awesome. The end. Ooh, now we want to know, different color. Now we want to know the measure of angle RS. Or excuse me, of arc RS. So, we have, remember, so here's 44 meters. That's our arc length. So I have 44 equals the measure of RS over 360 times the circumference, which is 2 pi r. And, oh, I know what r is. R is 15.28. Beautiful. So, oh yeah, if we want to get measure of arc RS all by itself. Oh, you can't even see the 2.28 over there. Whoopsie. There we go. If we want to get the measure of arc RS by itself, all we have to do is multiply by 360, because we're dividing by 360, so that gets that out of the way. Multiply by 360, and then we're going to want to divide by all of this. 2 pi 15.28. Divide by 15 pi... Oh wait, no, 2 pi. Woo! 2 pi times 15.28. Okay, and that'll get those to cancel out. So, 44 times 360 divided by 2 pi times 15.28. And that is 164.99 approximately. What's a way that we could check and make sure that that makes sense? Well, look at this angle. It's pretty close to 180 degrees, right? Hey, that's pretty close to 180 degrees. Makes sense. Cool. Let's check our answers. 8.38, 8.4, that's fine. 37, up, and look, they put the equals to, not the approximate. And 165, yep, and 164.99, cool. Beautiful, wonderful. Okay, next fun fact piece of extra information is degrees and radians. So remember back in chapter 9 when we were working on sine, cosine, and tangent, and how when we put it in our calculators, we could put it in degrees, or we could put it in radians, and we were always dealing with degrees before, but now we actually could play with radians if we wanted to, because I'm going to teach you about radians. So what is a radian? Here, this tells you how to convert between degrees and radians. And all this information on the right tells you about what a radian even is, where a radian comes from. So basically, it's the unit, when we're looking at arc length, it's the unit, it's a little bit hard to explain without talking about all of this, but the arc length associated with a central angle is proportional to the radius of the circle. So when we look at this, it's kind of like our formula for arc length, but without the radius. That's defined to be a radian. So 1 radian, if I split the circle up like this, 1 radian comes out to be about like that. That's what 1 radian is. Because if I have a radius of 1, the circumference of my circle is 2 pi. So, when we talk about there's 360 degrees in a circle, there are 360 degrees. There are also 2 pi radians in a circle. So when you talk about degrees, it's very important to put the degree symbol. And when we talk about radians, most people just leave it like that. We assume that if we don't see a degree, you're talking about radians, but you can also write rad or radians next to it if you want. So that's the main takeaway, is that in a whole circle there are 2 pi radians, which makes this pi radians, which makes this pi halves radians. You're going to learn about the unit circle next year. What fun. Oh my goodness. I love the unit circle. I really do. Yes. Okay, so if I want to go between degrees and radians, this is how I do it. You can multiply degrees by this or by this. I recommend you use this, because 2 pi radians over 360 degrees, if you cancel that 2 out of there, you get pi over 180. So these are the same thing, but this one is a simpler form. So I recommend that you use this one so you don't have to worry about any unnecessary, like, canceling or things like that. And another trick to remembering, because you see the difference between these is just that the 180 is on the bottom or the 180 is on the top. So the easy way to remember which one goes on the top and bottom is you want your units to cancel out. If I'm going from degrees to radians, I want my degrees to cancel out. And I'll show you what that means in our next example. So, remember, I'm either using pi over 180, pi radians over 180 degrees, or I'm doing 180 degrees over pi radians. Which one will I do? Whichever one cancels out your units. So, different color. I have 45 degrees, and I want to turn that into radians. Well, in order for these degrees to cancel out, degrees needs to be on the bottom. So I'm going to use this one. I'm going to use pi radians over 180 degrees, because now you see the degrees are going to cancel out and I'm going to be left with radians on the top. So all we have to do is 45 times pi divided by 180. And I get approximately 0.79 radians. And that's it. That's it, just multiplying by one of these. All you gotta do is multiply by one of those, and you're good to go. Okay, and now, you'll often see pi in radians. That's normal. You will often see that. Different color. 3 pi over 2. So now I have radians. So we can put radians. And I want to turn this into degrees. So that means I'm going to want degrees to be on top, and I'm going to want the radians to be on the bottom, so that the radians cancel out and I'm left with the degrees. So, that means I'm going to use this one. Pi radians on the bottom and 180 degrees on the top. So, before I go plugging this into my calculator, I can make things easy on myself. Look, the pi's already cancel out. And I don't have the pi's anymore. And I can do, I can divide the 2 by the 180 and just have 90 up here. And look at that. Now all I have to do is 90 times 3. Which is 270 degrees. Ta-da! So yeah, cancel out what you can. It makes the problem easier for yourself. Okay. Alright, we have one more extra example. Oh, well, let's check our answers first. Ooh. Ooh, they left it in exact form. Yeah, they left it in exact form. So they just canceled out the 45 and the 180. Let's see, they're both... Let's see, 180 is divisible by 45. Yeah, 180 divided by 45 is 4. That's where they got the pi over 4 from. So, be careful. Sometimes they might want it in exact form when you're talking about radians. So, pi over 4th looks good, and 270 degrees looks good. Booyah. Okay, last thing we're going to talk about is the area of sectors. This is the same thing as arc length, only now, like before, we were looking at a section of the arc length. Like I was looking at this section of the arc length. Now I'm just looking at a section of the area. So yeah, just like this picture shows. It is the exact same thing as arc length, but now we're doing everything inside of it too. We're doing the area of a sector. So, and you can see that the formula is exactly the same. You take the measure of that arc, divide it by 360, and then this, instead of being the circumference, it's not the circumference, it's the area. But that's it. You're still just taking a fraction of the area. So like we looked at before, if I'm taking half, if I want to know what the area of this sector is, it's half of the area. If I want to know what this portion, what this sector is, well, it's 1/4 of the area. So I'm just going to take that fraction out of 360. If I want to know what this is, it's something out of 360 times the area. It's some fraction of the area. So it's the exact same thing as the arc length. I would write this down. I would write down everything in the blue boxes if you want to. But remember, this is not required. Okay. Finding area of sectors. Color. So remember, the area of a sector is equal to that 70 degrees right there out of 360 times the area, which is pi r squared. So we have 70 out of 360 times pi 8 squared, which is, let's just show all of our steps. This is 64 pi. Can we do any canceling? Let's see. 4 divided by 60. That's okay. If you want an exact answer, cancel stuff out of there. This video is pretty long, so let's just do 70 divided by 360 times 64 pi. And we get approximately 39.1 inches squared, because we're dealing with area. We're dealing with area. And there you go. Let's make sure that we were correct. 39.1 inches squared. Oh, I didn't even notice they wanted the area of the large sector. So what we could do for the area of the large sector is we could do this same thing again. We could do, let's see, area of the large sector. But now this is just going to be 360 minus 70, which is 290 over 360 times pi r squared. We could do all of that, or we know that this area right here, we could just take the area of the whole circle and subtract this chunk and just get rid of that chunk. That sounds easier to me. So let's take the area of the whole circle. The area of the circle is pi r squared, which is 8. 8 inches is the, so pi 8 squared, which is 64 pi. And now let's just do this minus this. So 64 pi minus 39.1 is approximately, or because yeah, the 39.1 is approximate. So 64 pi minus 39.1 is 161.96 approximately, and that is inches squared. Let's see if we were right. Ha ha ha! 161.96.97, same thing. Same thing. Alright, perfect. And you can see I can't scroll down anymore. That is the end of our lesson today. Thanks for sticking through to the end to see all the extra stuff. You now have all the tools you need to be able to tackle... Whoa! Oh my goodness. Where'd we go? To be able to tackle these bonus homework questions. So good for you. For learning everything that you would have learned if we had been in normal school. Thanks for sticking around to the end. I appreciate it. I hope you have a wonderful rest of your day. Bye.